Hi students, in this video I will discuss the trick to find the hybridization. This hybridization questions frequently asking in the JEE and NEET examination. So definitely one question will be coming from this hybridization topic in every NEET examination as well as JEE examination. Now how to find the hybridization in a simple manner. So within 10 seconds we can find the that hybridization of the molecule. So for this we need to know the 4 points. So what are the 4 points we need to know here? First we will see, after giving one molecule we need to find the central atom of the molecule. Central atom of molecule we need to find central atom of the molecule. Second thing is find valence electrons in central atom. Valence electrons in central atom. Next one, find the surrounding atom. Next another one, find the surrounding atom valency. Surrounding atom valency. Right. So for central atom we should find the valence electrons. For surrounding atom we should find the valency. Now what is the meaning of valence electrons and valency, students? Valence electrons means number of electrons present in the outermost orbit is called as a valence electrons. Now what is the meaning of valency? The combining capacity of an element is called as a valency. Okay, right. So valence electrons means valence electrons. So number of electrons present in outermost orbit. Electrons present in outermost orbit. Valency means the combining capacity of an element. Combining capacity of an element. Right. So we will see what is the central atoms generally will be giving. So generally with the p black elements only will be giving in the hybridization. So in such cases, so we will see the what is the number of valence electrons in the case of the p black and s black elements. Let us see in case of the first A group elements. We will see here first A group elements, next one second A group, third A group, fourth A group, fifth A group, sixth A group, seventh A group, and finally zeroth group elements. In case of the first A group elements, what is the number of valence electrons, students? Valence electrons we will see here. So in this case, so number of valence electrons are 1, first A group elements, second A group elements, number of valence electrons are 2, third A group it is 3, fourth A group 4, it is 5, 6, 7 and 8. And next one, what is the valency of these things? Valency of these elements. So first A group elements valency is the 1, second A group elements 2, third A group elements is 3, fourth A group elements is 4. So up to fourth A group elements, number of valence electrons is equals to the valency. After fourth A group elements, what is the valency? Valency is equals to the number number of 8 minus number of valence electrons. So after fourth A group, valency is the 8 minus number of valence electrons. So here 8 minus number of valence electrons are 5. So here valency is the 3. So in this case it is 2. In this case it is 1. And finally it is 0. So this is the valency of the first A group to zeroth group elements. Let us see what are the first A group elements, students. We can say lithium, sodium, potassium, rubidium, cesium. Next one, second A group elements are beryllium, magnesium, calcium, strontium and barium. Third A group elements boron, aluminum, gallium, indium, thallium. Fourth A group elements are carbon, silicon, germanium, tin and lead. Fifth A group elements are nitrogen, phosphorus, arsenic, antimony, bismuth. Sixth A group elements are oxygen, sulfur, selenium, tellurium, polonium. Seventh A group elements are fluorine, chlorine, bromine, iodine, astatine. Eighth A group elements are neon, argon, krypton, xenon and radon. These are the S black elements and P black elements, students. So in this case we know the number of valence electrons and valency here. So from this we can able to find the hybridization by using our 4 points here. So 4 points is given. So central atom of the molecule we need to find. Next one valence electrons in central atom we need to find. Next one surrounding atom we need to find, and surrounding atom valency also we need to find. So if you know these 4 points, we can easily find the hybridization. So let us take an example. So example I am giving here SF6 I am giving. So in case of SF6, central atom is a sulfur. Central atom is sulfur. Sulfur belongs to a 6A group element, which means it has a 6 electrons in the outermost orbit. So assume there are 6 electrons. I am taking like this way: 1, 2, 3, 4, 5, 6. So here surrounding atom is fluorine. So fluorine valency is 1. That means it can form the only one bond. So you can take, there are 6 fluorines are there. It is forming 6 bonds with surrounding atom. 6 bond with surrounding atom here. So if you count the, so all this number here, some n number will come. Here n equal to hybridization. N is equals to the hybridization. So what is the hybridization, students, here? So hybridization, that is equals to the number of sigma bonds plus number of lone pairs. This is the only method which we are having, which we can able to find the hybridization as well as number of lone pairs on central atom. Okay, this is very important method and very easy method also to find the hybridization. And let us take the, if n is equals to the 2, we can say it is the sp hybridization. If n is equals to the 3, we can say it is sp2 hybridization. Next, n is equals to the 4, we can say it is sp3 hybridization. If n is equals to the 5, we can say sp3 dehybridization. If n is equals to the 6, we can say it is sp3 d2 hybridization. If n is equals to the 7, we can say it is sp3 d3 hybridization. Right. So in this particular molecule case, there is a number, n value will be coming, it is a 6. If n value is 6, we can say here sp3 d2 hybridization. Okay, right. Let us take some more examples here. So here n equal to the number of sigma bonds plus number of lone pairs here. Okay, now we will say here some examples. I am taking here NH3. In case of NH3, central atom is a nitrogen. Nitrogen has 5 electrons in the outermost orbit. That's why I am taking 5 electrons like this way. Surrounding atom is hydrogen. Hydrogen valency is 1. So there is 3 hydrogens are there, which means, so it forms 3 sigma bonds, and there is a 2 electrons will be left here. So these 2 are the lone pair of electrons. Okay, right. So here n value is equals to the 4, which means it is the sp3 hybridization. Okay. So in some cases there is central atom forms the double bond. For example, you can take here carbon dioxide. In case of the carbon dioxide molecule, central atom is the carbon. So carbon has 4 electrons in the outermost orbit, right? So here surrounding atom is oxygen. Oxygen forms the two bonds. In these two bonds, one is sigma bond, it is forms, other one is a pi bond here. One is sigma, other one is pi. That means what? Number of sigma bonds only two only. That means n is equals to 2, which means hybridization is the sp hybridization. Right, next one, in case some molecules charge will be given, for example nh4 plus. In case of, if the charge is given, okay, simply we need to remember 2 points here. If a positive charge is given, if positive, simply we can say in case of cations, in case of cations, in case of cations, remove the same number of electrons, remove same number of electrons from central atom. In case of anions, in case of anions, add same number of electrons, add same number of electrons to central atom, right? So same number means what? Whatever charge is present over here, that number only. So for example, you can take, I am taking here ammonia molecule, you can take here, so ammonium molecule nh4 plus. In this molecule case, nitrogen is central atom, so it has generally 5 electrons in the outermost orbit, but since it is the cation, we should remove one electron here. Now what will be the hybridization? There is a 4 surrounding atoms hydrogen, we can say here hybridization is the, it forms the 4 sigma bonds. So which means hybridization is what here, students? sp3 hybridization, okay. And one more, you can take the CO3 2 minus. In case of this CO3 2 minus molecule, central atom is the carbon, and there is a 4 electrons in the outermost orbit generally, but it has the 2 negative charge, which means we need to add the 2 more electrons here, right? So oxygen valency is the 2, that means it forms the 3 sigma bonds to central atom. That means n value is equals to the 3. If n value is 3, hybridization is the sp2 hybridization, right? Next one, I am going with another example, PCl5. Central atom is the phosphorus, it has a 5 electrons in the outermost orbit. Surrounding atom is chlorine, so the 5 chlorines are there, it forms the 5 sigma bonds, which means hybridization is the sp3d hybridization, right? Next one, if you take the XeF6, in case of XeF6, xenon is central atom, so it has the 8 electrons in the outermost orbit, 2 3 4 5 6 7 8. So fluorine is the surrounding atom here, there is a 6 fluorines are there, 6 fluorines will form the 6 sigma bonds, and one lone pair is present here, that means n is equals to the 7. If n is equals to 7, hybridization is sp3d3 hybridization. Next one, if you take the H2O, H3O plus. In case of H2O molecule, central atom is oxygen. Oxygen has 6 electrons in the outermost orbit, and there is a surrounding atoms, only 2 hydrogens are present, and remaining are lone pair of electrons. That means n value is equals to the 4, which means sp3 hybridization. In case of the H3O plus, central atom is oxygen, similarly it has the 6 electrons in the outermost orbit, but it has plus charge over the central atom, that means we should remove one electron. So there is a 3 surrounding atoms, hydrogen, and even these two we can consider as a lone pair of electrons. Again here n value is equals to the 4, we can say it is sp3 hybridization, okay, right? So more examples, so please try by yourself. XeO4, PCl6 minus, PCl4 plus, I3 minus, I3 plus, right? So that's it about the trick to find the hybridization. I hope you understood this video. So if you like my video, please subscribe my channel. Thank you very much, students.